Okay, so I did this whole lesson, but it was too long and then the video got deleted. YouTube deleted it because they couldn't upload it. So I'm just gonna try to talk it through this time and go really quick. When you're adding and subtracting rationals, it's really important to remember how to do it with just regular fractions. When you have a regular fraction, you just get a common denominator. So this guy needed the 4, this guy needed the 3. It's algebraically sound to be able to do that because 4 over 4 is 1 and 3 over 3 is algebraically 1. So you're not changing the problem. Basically you just need, this guy had a 3, so we did 3 over 3. This guy had a 4, so we went 4 over 4. Then only the numerator changes. 9, well, they both change, but 9 over 12 plus 40 over 12. I mean, only the numerator matters. I can almost cover this up down here and say, okay, now I just do 9 plus 40 is 49th. We don't change this to be 12 plus 12 equals 24. That doesn't happen. The denominator doesn't change, only the numerator. It's a little remembering recap on doing adding and subtracting fractions. So then I'm just so bummed this all deleted. I literally worked so hard on this lesson and now I have to just walk you through it. But 6 over AB, and then this guy needed a B over a B, so because that would match the other denominator. So now they both have AB over AB. You can virtually cover up the denominator because only the numerator is really what changes. The denominator does not. We just combine that numerator together. So that's how you do it in a simpler way. Up here where we have x squared y and x, this fraction needed x over x to be able to match the two bottoms. So now we have 3 over x squared y plus 4x over x squared y. Now both of the denominators match. We can combine the numerators. I'm sorry if I'm going really fast. I'm just trying to make sure these YouTube videos don't last super long. Also, make sure you pause it if you want to see it more in depth. The orange are the original problems. This was blank, and I went through the whole lesson, and then it got deleted. But so if I have 1 over x plus 1 and 2 over 3, so this side needs the 3 over 3. This side needs the x plus 1 over x plus 1. You aren't allowed to just be like, oh, plus 2 and x plus, it's x plus 3 and x plus 3. No. Can't do that. So you really have to give what the other one has. So she needed x plus 1 over x plus 1. He needed 3 over 3. Now I have 3 over 3 times x plus 1 plus 2 times x plus 1 over 3 times x plus 1. And now we have that same common denominator of 3 times x plus 1, 3 times x plus 1. We'll end up, our final answer will have that as well. When I distribute in that 2, it makes 2x plus 2. So 3 plus 2x plus 2 makes 2x plus 5 now as the numerator over that common denominator. I was trying to show that you could drop in this 3x plus 3 down here, and that's what that little scribbly dead thing is. Okay, now it's just one more example of the same. I actually, for time's sake, these two are so similar. I'm actually just gonna show you the screen, and you could pause it for a sec, but these two are so similar, I'm only gonna do one of them. It's really just multiplying what the other one needed, and then 3 times x plus 2, FOIL it out, and then combine like terms. But I'll explain this one in more detail. So you have this and this. That's the original problem. This guy needed an x plus 2 over x plus 2 because that's the denominator of this side, and multiply this one by x plus 3 over x plus 3 because that's the denominator of the other side. Now we have 4 times x plus 2, 4 times x plus 2 over x plus 2 times x plus 3, and 2 times x plus 3 over the common denominator x plus 3, x plus 2 over x plus 3. Then if I just FOIL it out, 2x plus 6 and 4x plus 8, the 4x and the 2x can come together, and then the 8 and the 6 can come together. If I take a 2 out of them, nothing else cancels. This 3x plus 7 doesn't cancel with anything, but it's worth looking at. So either this one or this one would work, I mean. Yeah, it's really just honestly multiplying this out and then combining the numerator. It's always so tempting though when you're at this stage and you're like x plus 2 over x plus, I could cancel those. But you just added in the x plus 2. So you don't want to cancel out what you're adding in, what you're multiplying in. Not adding in, multiplying in. Then when it goes to subtracting, so subtracting is just a little bit different. So again, the original was this orange. I'm sorry, I went through all of this really in depthly and it was like a 25-minute long video. Oh, they got deleted. Can you tell I'm upset about it? Can you tell? Can you tell? Okay, so this side needed x plus 1 because that's what the other one had. And this side needed x plus 2 because that's what the other one had. So now we have 5 times x plus 1 over x plus 1 times x plus 2 minus 3 times x plus 2 over that common denominator. Now we have those common denominators, and we really can cover this up and only work with the top. It becomes 5x plus 5 minus 3x plus 6. Now, this is the only difference between pluses and minuses, that the minus has to be now distributed to everything in the back over that common denominator. So now we have 5x plus 5 minus 3x minus 6 over the common denominator. And when I combine like terms, 5x minus 3x is 2x, 5 minus 6 is minus 1 over the common denominator, but we don't just leave common denominator, so I wrote in what that common denominator was. I'm really just getting you to grasp that the denominator almost doesn't matter at all. It's once you get it, then you kind of can leave it, and you only deal with the numbers on the top, the numerator. Okay. Really want to make sure I don't get cut off again. Okay, so here's one more minusing one. This is the original problem. So they needed the x plus 4s, they needed the x plus 3s. And then you have, okay, 4 times x plus 4 over x plus 4 times x plus 3. And that is a really funky 3 that I thought was hilarious. And then minus the 2 times x plus 3. 2 times x plus 3 over x plus 4 times x plus 3. And it's minus. So that's going to end up distributing to that whole back thing. Foiled out the 4, distributed the 4, distributed the 2, and then put the minus in. Now our numerator is 4x plus 16 minus 2x minus 6 over the common denominator and combine like terms. So if you need to pause the video and look at how I got that, bada bing, bada boom. Okay, now here's the harder one. I want you to see what the original problem had, which I did have before the video got deleted. Did I mention that my video got deleted after I put so much effort and time into it? Yeah, cool, sick life that I'm living. So this originally had an x squared minus 4. My point was that you could multiply this side by x squared minus 4 and this side by x plus 2 over x plus 2, but it ends up making this huge mess. If one of the denominators can factor first, factor the denominator. Factor the denom first. The denom first. That's what you should do first. The denom, the denominator. So this was x squared minus 4. I factored into this, and I ended up scribbling it out because I just wanted to be like, hey, look, this is what it goes to. Now this side has x plus 2, x minus 2. This side just had the x minus 2. So I had to give him in yellow the x plus 2 that they were missing. So x plus 2 over x plus 2, FOIL it out. Now we have x minus 3, that old guy, plus the new numerator, all over the common denominator. Again, you can basically cover up the denominator and just deal with the numerator. The denominator is the only thing that changes. All right? Combine like terms, bada bing, bada boom. And the last example, so I ended up making it a minus, make it a little bit harder. But so x minus 4 over this whole thing minus 2 over this whole thing. If you can factor the denominator first, do it. So I factored this denominator. This guy can't factor. The only thing this side is missing is x plus 4 over x plus 4. This little side note was it can be a lot harder. Like let's say that this bottom was x squared minus 9, which from difference of squares would go into this. If you have two different factors here and then two different factors over here and none of them matched, let's say it was like this with that x plus 3, x minus 3 over here. This whole thing would have to be multiplied by x plus 3 times x minus 3, and this whole part would have to be multiplied by that x plus 4 times x minus 2. It gets a little more complicated. maybe on an extra credit problem. Okay, so now we're here, and it's like x minus 4 minus 2x plus 8, 2x plus 8. But the minus distributes to both of those back ones in the back. So x minus 2x goes minus x, 4 minus 8 goes minus 12, all over the common denominator. So that's how you add and subtract. I'm sorry this feels like rushed. I just feel frustrated that I did all of this, and it got deleted! Anyways. Hopefully it helps. Happy Friday. You guys rock.